Alright, welcome back everybody. We are in Unit 2. This is our first lesson. And this entire unit is based around the derivative. So, to start with the derivative, we first have to learn about instantaneous versus average rate of change. You probably already know this, because I told you this before. But this is the average rate of change. And this is what we call the secant line. That's what I'm drawing here, the secant line. This basically graphs the linear line of the slope of the average rate of change. Right? And we already said that instantaneous rate of change is one that gets microscopically small to the point where it's basically on the point. And we know that we can define microscopically small things or large things. So microscopically small. Those large things with limits. Which takes me into the derivative. The derivative is the instantaneous rate of change. Alright, so that's pretty simple enough, right? So basically, what we're going to do is we're going to define some things, some fundamental things, alright? So these are two fundamental limits that you're going to have to know. Two fundamental limits. They will be tested again and again. You will be tested again and again on these. These are the most important. I cannot stress how important these specific ones are. It basically states that let's take a function g of x. G prime of x is going to be equal to the limit as h approaches 0 of g of x plus h minus g of x over h. Because we're trying to graph that limit. Remember, we're trying to graph the smallest average rate of change possible. So we need to make it so where h is the smallest number possible. That's basically what we're trying to ensure. Meaning we have to take the limit as h approaches 0 in order to get the proper derivative or the proper instantaneous rate of change. The definition of a derivative at a point is a little different. G prime of a is going to be equal to the limit as x approaches a of f of x minus f of a over x minus m. This is basically a less general way to define the derivative, since you're doing the same thing. You're trying to make that average rate of change as little as possible, meaning you're basically defining a at the same point as you're defining x. Alright, so that's the basics. I'm going to define some notation that you're going to need to know. Obviously, you see the tick mark. There is, the derivative is going to be indicated by this. This is the most common notation. We call this the Lagrange notation. And then there's also d dx of g of x. That's also the derivative. And then there's also more ways to define x, I mean the derivative, but these are the only ones that we use. All right. So let's do a few practice problems with this. Why not? Let's do a few practice problems with some functions. Let's say h of x is going to be equal to cosine of x. And let's say we're trying to find f prime of pi over 2, right? Okay, so what's the first thing? I mean, h prime of pi over 2, my bad. H prime of pi over 2. So the first thing that we do is we set up our limit. The limit as x approaches, which one do we use? We use the derivative at a point. Remember that. The limit as x approaches 3. Oh, by the way, you do need to know, for the definition of a derivative at a point, you do need to know, yeah, you already know f of a, so it's fine. So the limit as x approaches pi over 2 of f of x of cosine of x minus cosine of pi over 2. It's just 0 over x minus pi over 2. And then basically what you can do is you can alright, I'll just tell you what you should be doing. So that's going to be equal to cosine x for x minus pi over 2. And then you can just keep going on your way down. From here you can just keep what you should do is you should rationalize. So you should multiply, and what you're eventually going to get is h prime of pi over 2 is going to be equal to -1, right? That's eventually what you're going to get. All right. So basically, the definite, so let's do a little bit of a simpler one. Y is equal to x to the 4th plus x to the 3rd. All right. And let's not call it y. Actually, yeah, let's call it y. All right. Y. This is an important time to learn certain notation. So we can actually put this in brackets, right? And we can go d dx on both sides if it asks us to find the derivative. That means dy dx is equal to 4x cubed plus 3x squared. You do that whenever there's another variable y, usually. You can also do the f prime thing. That's my favorite, but this is one of the most fundamental notations. And then you're supposed to find dy dx at a, like, this is the general point of it, right? So that was just the answer for it. Let me actually show you how to do it, though. So that means dy dx is going to be equal to the limit as h approaches 0. The reason I was able to do that so fast is because of something we're going to learn next lesson. Learn something faster. But for now, we can stick with this. F of x minus, f of x plus h, my bad. What is that h? Limited as h approaches 0 of f of x plus h minus f of x over x over x minus h over, my apologies, just h. All right. So the thing we do is we have to start by plugging in this function. So let's make it a little simpler, because I don't want to I'm not trying to, like, put that whole thing out, right? That'll take quite a long time. You can if you want to. Try to do that, like, try to extend it out, but I don't feel like expanding that function for now. So that means x plus h squared plus x squared minus x squared minus x, meaning over h, meaning these two cancel out. Then you get the limit, and as h approaches 0, x squared plus 2hx. Oh, I definitely did this wrong. My apologies. This should be x plus h squared plus x plus h minus x squared minus x. Meaning you can cancel this out, you can cancel this out. And then that's going to be equal to x plus h squared plus h minus x squared over h. You can cancel those out. And then at this point you can factor an h out, so I'm just going to do that. That means the limit as h approaches 0 of this function will be excuse me. It'll be 2x plus excuse me. It'll be 2x plus h plus 1. It'll be, because this is 1, yeah. It'll be 2x plus h plus 1. And since we know it's the limit as h approaches 0, that means it'll be 2x plus 1. And that will be our derivative. Alright, I mean, yeah, this is going to be a quick lesson. That was pretty simple, honestly. Just defining that derivative. You're also going to need to estimate derivatives. You're going to need to do some other stuff as well. I can show you how to estimate a derivative at a point. That will be next lesson. So for now, let's do one more practice problem. Actually, let me give you 2 homework problems this time. So homework. These 2 problems. All right. So this is problem 1. It's problem 2. This is going to be find f prime of x if f of x is equal to 3x squared plus 3. All right? And then find dy dx at a point x equals 2 if y is equal to x cubed. All right. So do these 2 problems. And this is your homework. So I'll see you next lesson. That was a pretty short lesson. Those were just the bread and butter of the derivative. I might have gone a little fast, so we'll just review over some key fundamentals maybe tomorrow, especially when we're applying the power rule and other new derivative rules, because we haven't gotten into any derivative rules yet. These are just the basics of the derivative. Yeah, but for now, try your best on these 2, and then I'll see you next lesson.